Hi, welcome to crackingmba.com. Today we are going to talk about relative speed, which is one of the several concepts in time and distance. Today we are going to talk about of all the several concepts that are available in time and speed, such as average speed, relative speed, boat and streams, races, circular tracks, and clocks. Today we are going to focus only on relative speed. For the other videos, for other concepts, you can always refer to the other videos which are listed from 1 to 5 below. So what is relative speed? Relative speed is the speed of one moving body as observed from another moving body. So if you have experienced traveling on an expressway, you would have noticed that when you're traveling in your car, you find another car overtaking you, it seems to be moving at a specific speed, right? That speed at which you observe this other car which is overtaking you is the relative speed. So if your car is traveling at 80 kilometers an hour and you find another car overtaking you at a speed of 100 kilometers an hour, you find that the car is moving at a steady speed of 20 kilometers an hour. So there are two possible scenarios here. Both the cars could be moving in the same direction, or both the cars could be moving in opposite direction. So let's take both the scenarios here. So in the first scenario, we can see that there is a purple car and a red car, and both of them are moving in the same direction, one at 100 kilometers an hour, another at 120 kilometers an hour. So the relative speed between both of them is 20 kilometers an hour. So if I were sitting in this blue purple car, I would notice that the red car is traveling at a speed of 20 kilometers an hour. Here is another scenario when they move in opposite direction. So we are saying that if they move in opposite direction, the purple car is moving at 100 and the black car is moving at 120, then the purple car sees the black car approaching it at the speed of 220 kilometers an hour. So if someone is sitting in the purple car, he can see another car coming at racing towards that car, racing towards the purple car at 220 kilometers an hour. Now let us see how we can apply these concepts. So just as a formula approach or just as an expression approach, you can find that the relative speed in the same direction is q minus p, and the relative speed in the opposite direction is p plus q. Okay. Now let us see the different scenarios. So some scenarios here which you encounter for such questions are objects with length and objects considered as a point. So objects with length include trains or river barges, right, which have a specific length, and you need to consider that length in the calculations. Some objects such as human beings or cars or other small vehicles can be considered as a point. They don't have a specific length for calculation. So let us see how we can see the examples and identify. So some of the examples of objects with length include a train of length 100 meters crossing a pole, or a river barge of 120 meters crossing a man on a river bank. So a pole and a man are the points, are considered as points. Objects which are considered as a point, as we discussed, is a man running at 10 kilometers an hour and overtaking another man, or a man running at 20 kilometers an hour and crossing a pole, or a man or a car overtaking another car. So these are considered to be points without too much of a length. So we don't consider the length of the car in such numericals because the length is considered too insignificant. So let us now look at some basic questions. So first we'll talk about solve some basic questions which cover the concepts, and then we will talk about some advanced questions. So just the basic purpose of the basic questions is so that you can just get an understanding of what we discuss in the basic concepts. So car is moving at 60 kilometers an hour on an expressway, another car is moving in the same direction at 100. What is the speed of the faster car as per the passenger in the slower car? So this is basically the relative speed, and we are saying it is q minus p, which is 40 kilometers an hour. Okay, so let's move on to the next question. So here we are saying 80 and 40, and they're moving in the opposite direction. Okay, so clearly it is p plus q, which is 80 plus 40 is 120 kilometers an hour. Let's now see another question. So two athletes start a race from the same point at 8 kilometers an hour and 6 kilometers an hour respectively. So what is the distance between them after 18 minutes if they move in the same direction? Okay, and the next question will talk if they're moving in the opposite direction. So you need to visualize, if they're moving in the same direction, it is the relative speed with the subtraction. If they're moving in the opposite direction, it is an addition. So here we are saying they're moving in the same direction. So what is the relative speed? 8 minus 6 is equal to 2 kilometers an hour. And we are saying what is the distance in 18 minutes? So 18 minutes converted into hours is 0.3 hours, and the relative speed is 2 kilometers an hour. So we will find that the total distance between them will be 2 into zero point 0.3 is 0.6 kilometers. Okay, so this is how we apply the relative speed concept. Now let us look another question where they are moving in opposite directions. So if they're moving in opposite directions, then this relative speed is 8 plus 6 is 14, right? And converting 18 minutes into hours is 0.3 kilo hours. So the same question we are seeing how what happens when they move in opposite directions. Okay, so again the distance is nothing but 14 into zero point 0.3 is 4.2 kilometers. So here you notice that if they're moving in the opposite direction, it's just the addition of the total distance that they would have covered between each other. So if they're moving in the same direction, it is just the relative speed after the subtraction of their speeds. Okay, so let's now move to the next question. A train of length 200 meters is traveling at 76 kilometers an hour and overtakes another train of length 250 meters traveling at 40 kilometers an hour. How long will the faster train take to overtake the other train? So what we are saying here is we are trying to solve a numerical in terms of trains with specific length. So what is the relative speed of the trains? 76 minus 40 is 36 kilometers an hour, which is nothing but 10 meters per second. The total distance is the total lengths of both the trains. Now whether they travel in the opposite direction or the same direction, the total length is nothing but the length of the sum of the lengths of the trains, because that is how much of distance has to be covered. So total distance is 450, time taken is 450 by 10 is 45 seconds. So the key concept here is the total distance will be always the length of both the trains in either same direction or opposite direction. Now here we are saying the opposite direction. So again, same story. Only difference is relative speed is sum of both the speeds. So 36 plus 72 is 108, which is 30 meters per second. Total distance is 180 plus 120, which is 300. So total time taken is 300 by 30, which is 10 seconds. Now let's look at intermediate level of question. Okay, so we are saying two cars are at a certain distance and they're traveling towards each other at speeds of 30 and 60 kilometers an hour. So if they meet in 12 seconds, what is the distance between the two cars? So here again, the relative speed is 60 plus 30, which is 90, or 30 plus 60, which is 90 kilometers an hour, or 25 meters per second. And assuming the total distance is d, they're going to cover it in a time of 12 seconds. Okay, so total distance that was there between the cars is nothing but 25 into 12, which is 300 meters. Now let us solve some little bit advanced questions. Okay, so what we are saying here is a train overtakes two cars traveling at 30 kilometers an hour and 60 kilometers an hour in 10 and 20 seconds. So what is the length of the train? So here what we are trying to say is we know the relative speed of the train with respect to two moving objects, which are cars. Okay, so relative speed of the train with respect to car 1 is s minus 30, where s is the speed of the train. Relative speed of the train with car 2 is s minus 60. So we know that the length of the train is nothing but the relative speed into time taken to overtake that particular car. So car 1, the relative speed is s minus 30, time taken is 10. So length of the train is s minus 30 into 10. And relative speed for the second car is s minus 60 into time taken is 20. So equating the length of the car in both length of the train in both the cases, we get this equation. Okay. Now we given this equation, we can solve it and get s is equal to 90 and length of the train is nothing but solving this 500 by 30 meters. So if you notice one important thing here in this equation, we are saying s minus 30 is in kilometers an hour, but 10 is in seconds. So we are not doing any conversion of seconds into hours or kilometers per hour into meters per second, because this is an equation and all the conversions will get you can strike off the conversions. So that's why you don't need to do the conversions. You can just multiply like this. Okay. So, but you need to be careful when you're doing the actual calculation of the length of the train. So here we're saying 90 minus 30 is in kilometers an hour. We are converting into meters per second and then multiplying by 10 to get the meters of the length of the train. Let's move on. So this is about races. So these kind of questions come frequently in several competitive exams. So in a 500-meter race, A races ahead and finishes the race 30 seconds ahead of B by a distance of 120 meters. So what is the speed of A in this case? So typical mentality would be to see to try to divide the total race divided by S1 and S2 and say 500 by S2 minus 500 by S1 is equal to 30 seconds and solve some big equation. But all that is not required. So what you can do is we are saying when A finishes the race, B is behind by 120 meters and by 30 seconds. So basically B covers that gap of 120 meters in 30 seconds. So speed of B is nothing but 4 meters per second. Okay. Now, what is the total time taken by B to finish that race? 500 by 4, which is 125 seconds. Now, we know that A takes 30 seconds less than B to complete this race, because that is what we are given, right? 30 seconds ahead of B. So the total time taken by A is 96 seconds to complete the entire race, and hence the speed of A is 500 by 96 meters per second. So this is how we solve this question without having any equations. Okay, too many equations. Now let's look another type of question. So we are saying in a 100-meter race, A finishes the race in 45 seconds and B in 60 seconds. By what distance does A beat B in the race? Okay, so this is a slight application of the concept we learned in the previous question. Okay, so we are saying B is slower than A by 15 seconds at the time A finishes the race. So what is the speed of B? It is nothing but 100 by 60, because that is the distance and time. Now distance between A and B at the time A finishes the race is nothing but 100 by 60 into 15, because 15 is the gap between A and B at the time of A finishing the race, because B is slower than A by 15 seconds. So the total distance between A and B when A finishes the race is 25 meters. Okay. So this is how we can apply the concept of relative speed. So we have just covered some numericals, but you can attempt more questions in the mock test on the topic of time and speed, relative speed in the Android app. Thank you.